Hello, everyone. Welcome to the keynote session of this afternoon. I hope you have found the morning session to be fruitful and you're ready for the next session coming. So today we are very fortunate to have Mr. Shajay Bhooshan with us. Mr. Shajay is the Senior Associate of Zaha Hadid Architects, where he co-founded and heads the research activities for the Computation and Design Group, or CODE. He also works as a studio master at the AADRL Master's Program in London. He pursues his research in structure and fabrication-aware architectural geometry as a PhD candidate at the Block Research Group at Etihad Zurich. Previously, he has worked at Populous, London, and completed his MPhil from the University of Bath and MArch from the AA School of Architecture, London. Shajay has published in scientific journals and conferences, along with contributions to architectural discourse through architectural design and other magazines. He's taught and presented work at various professional conferences, events, and institutions across the world, including the AA at London, Etihad Zurich, Polytechnic of Milan, and Bari, Tongji University, Shanghai, SIGGRAPH, Autodesk University, etc. The list goes on and on. He's also made curatorial contributions to various exhibitions of Zaha Hadid architects, including the Venice Biennale in 2012 and Zaha Hadid Memorial Exhibition in Venice 2016, apart from the shows in Mexico, UK, USA, and Taiwan. The title of his keynote today would be Cumulative, Collaborative, Disruptive, Architectural Geometry in Research and Practice, and its imminent mainstream future. So we are very fortunate to have Shajay with us today. And without further ado, please welcome Mr. Shajay Bhooshan.
Thank you. Let me just share my screen. Is that working?
Yes, perfect.
Yes, perfect. Okay, yeah. Thank you for the introduction, Sirapong, and also many thanks for the invitation in the first place to Valaiporn and the organizers of CAADRIA and the university and so on. I was in Bangkok last year and I was hoping to be there physically this year, but this is as close to the real thing, and hopefully we get to meet in person sometime in the near future. So in the meantime, the content of the presentation is more or less, as Surapong mentioned, I just changed the title slightly because our thinking has evolved in the last year quite rapidly. So as Surapang mentioned, my name is Shajay, um, and I work currently at the Architects, where I co-founded the computational design team, Code, and I also teach at the AA and learn at Block Research Group in ETH, and previously did some learning at University of Bath. So myself and my team, like, we feel quite fortunate to work in a company, a global company with talent from all over the world. I think 60 different countries, and spread between Asia to Latin America. Uh, we feel fortunate also that, you know, our colleagues and peers and seniors preceding generations are manifesting these amazing buildings, including these two that got completed last year, the Beijing airport and the Soholeza tower with the largest atrium. Um, and so we're also fortunate to witness not only the physical manifestation of this, but also like the genesis of, and also all the sweat and detailing that goes into these buildings. And lastly, that allows us as a team to focus on a little bit further ahead, the near imminent future, and how we can shape that with new technologies. So we get to play in a serious way because our peers and colleagues are really at the bleeding edge of architecture and a very enthusiastic and motivated group of people. Um, so we, as a team, kind of tend to research these kind of geometric and uh, so-called computer-aided geometric design technologies, CAGD technologies, and its relationship to more mainstream BIM practices. And so we've been doing this for the last 15 years or so, and now a lot of this is becoming available in a more mainstream way, and we feel very enthused by like these recent developments, both by the Block Research Group on the one hand to bring bleeding edge research to make it available to a much larger, wider audience, and also practice-based BIM experience and BIM from Bureau Happold Engineering. They're making it available through these computational frameworks. So very exciting time to be in practice in London. um, so that's why like I felt that like we are in a position to talk about the real promise of digital design and robotic construction as it is maturing very rapidly, which is citizen-centric cities or citizen-centric built environment, in some ways, like for human betterment and through effective resource utilization. So which I believe is the real promise of digital design and robotic and advanced manufacturing. So the talk will briefly kind of situate like architectural design and urbanism of such cities, the social and physical technological layers that might need to interact, and also a first real world attempt that we recently um, tried to launch, and then hopefully will bring to fruition over the next year. And so finally conclude with like ideas related to how architecture is like not only physical anymore, it is a kind of cyber physical hybrid entity or kind of augmented reality. So what do we mean by citizen-centric cities? Sorry. It is from an architect's perspective, not a policymaker, not legal, not financial, and it is a perspective that is informed by a computational design and digitalized construction perspective. And it is also our own history from a parametric and a kind of tectonic perspective. And by citizen-centric cities, we had, I mean, it is in the spirit of inquiry and belief that cities make us happier and better, and that cities are entrepreneurial opportunities, they're democratic, and also they're techno-optimistic. So those are the kind of qualities that predicate our interest in these kind of cities. And participatory cities, like, you know, we've been trying to research this at the AADRL, where I first studied and now teach for the last 14 years. That you know, we first came to participatory cities through participatory housing, so which was the original idea of like how you can make housing developments, mixed use developments, more participatory, more resident centric or inhabitant centric. So now, since 2020, since this year, we think we can expand that out to small scale cities like 5,000 people or 10,000 people. So giving you a broad overview, like the whole idea, at least for us, kind of started with like around early 2000s by the seminal team and project called RAM TV at the ADRL, and within which there was like an article published about how communities, residential communities specifically, can self-form and self-govern as much as possible. So it was a kind of use of online technologies. This was pre-Facebook ideation and speculation that like you can use web technologies to create online communities and subsequently use digital construction to produce mass customized housing. So and so in since 2015, my partner and myself have tried to pick up this thread in view of the rapidly maturing digital design and also social technologies and also constructional technologies of robotic manufacturing and you know, DFMA, or design for manufacturing and assembly, and so on. So over the last 5 years, we have tried to anticipate you know, through graduate researchers and our own effort and collaborative efforts, we have tried to research this idea across many core topics. For example, the first one of the main topics has been about how to spatially organize communities. Can the communal synergies be physically manifested, particularly in like kind of live work communities, which were quite common in London before the war. So like the ideas of a top shop or live work ironmongery or a bakery and so on. So can we have something like that, was one of the topics of exploration. And then that was for long-term communities, and then we also explored similar things but for short-term communities, like a lot of you know, students and young professionals that like come in and leave London at an average tenure of 2 to 3 years maximum. So how can we address that? Another topic we like begin to emerge is the idea of gamification of these, how we can leverage game technologies, but also game theoretic mechanisms to arrive at negotiated solutions between sharing and resource pooling and so on. And across all of these efforts, the main idea is to kind of challenge the 100-year stranglehold of this architectural diagram of the Maison Domino, and its pairing with a technological equivalent of the NAB patents and reinforced concrete construction, and so on. So how we can revisit this in the 21st century, because it was enormously successful, but also it left quite something to be desired in the effect it had. So to take on the positives whilst avoiding the negatives, let's say. So we try to revisit across all of these efforts the idea of a Maison Domino and how we can construct a new tectonism for residential or domestic architecture in view with emerging technologies. So since last year, with the kind of relative success we had for the last 5 years, which I will speak about a bit more towards the end of the real world instantiation of some of these ideas, we now feel that it is time to start thinking about participatory cities. And that's what we are doing now. Just to give you a glimpse of like fresh work from the DRL from this year. The idea is to create platforms, leverage digital web technologies, but also real-time technologies of interaction and pairing virtual and real worlds in some sense through a architectural technology layer. And so the idea is to kind of have a space of experimentation and also speculation and forecasting and predicting of what might be the kind of various through gameplay mechanisms or just role playing and so on, like, so we can keep track of motivations. And so it's more a speculative idea to figure out what might happen if you allowed, if you revisited urban development from first principles. So in that sense, we see participatory cities as composed of two main things, two main layers. So the base physical substrate of industrialized construction, and then the social technological layer of governance technologies. So what do we mean by governance technologies? When it comes to governance of the built environment, we all know, like, it usually relates to taxes and policies of real estate, zoning laws, infrastructure development plans, transport requirements, parking laws, and all of these various laws that and governance of those that usually multiply and proliferate quite rapidly. It's to see, can we introduce a technological layer for governance by first principle? So which means, what is the first principles of governance of all these policies? That we have to effectively allocate resource. We have to take speedy decisions such that we deliver services to inhabitants. So, and what are the challenges of such technologies? First of all, it has to be a low risk environment because we cannot make expensive mistakes on the built environment. And also there needs to be a very fluid interchange between experts, oversight like planners, architects, constructors, and so on. But at the same time, there are very, very many number of stakeholders like the citizens, who are affected by these decisions. So how can these two interact? How can we provide agency to the non-experts who are affected by expert decisions? So those are some of the challenges. And we thought, our thinking is that this is where games and game technology and their inbuilt mechanisms of user choice, actions, feedback are ideally suited. And in addition, there's all of these game theoretic mechanisms, options, trade-off management, and so on. And so, for example, consider this.
And developers have to weigh millions of competing factors. Let's take a dense neighborhood with lots of housing. Without careful planning, that density could have unintended consequences, like worse traffic or tall buildings that cast shadows onto public spaces. In other words, good planning requires a holistic understanding of the trade-offs involved.
So it's, even though, Sidewalks Lab and Google are talking about the right things, trade-offs and participation, but their design systems are entirely centralized. They're not participatory. They're not democratic. It's a centralized expert system that goes through millions of options, and then it's executed in one go. So it is not as transparent as it could be. Contrast that to where we are coming from, is to say that we definitely can leverage and use AI systems, but they are just a non-human player within a game, or they can be used to simulate human gameplay, forecast scenarios of the social layer and the interaction layer. So here we're just simulating 80 players trying to rent and share spaces as they go, and also share resources and transact between each other in a kind of small economy of sorts. And then we keep track in this kind of simulated gameplay, like how many transactions happen between which of the inhabitants. And the black is a kind of transactions with the community, like as a whole. And you can see that through every various time instances that changes. Sometimes the community has to invest more, and sometimes it has to invest less. So it's a kind of equivalent of a voluntary tax. And that's one side we think like game technologies are very useful to explore. The other is obviously the social layer that are inbuilt to a lot of these game technologies. Like you can hook it up to a Facebook community and try and use Facebook for real, doing good stuff rather than just while away your time. And Facebook also has a lot of these AR technologies built in. And so we could leverage. So this is like a kind of simple AR app that we built, where people can like choose various things that they want: playground, little bedrooms, and so on. So it's a kind of simultaneous gameplay between multiple people. And we can also go entirely blue sky with this, where we can at least speculate like how to design for all of this choice, like so that it's not just like a car where the choice is related to only the color of your seat or the type of the seat, but we can have spatial choices ranging from what kind of things people want, like from rock climbing to gyms, and but at all the time, like that all of these things are physically guaranteed to be viable. So it's it's a very highly curated design space with enough variety to offer to various inhabitants. So so that's what we mean by governance technologies, like to look at self-formation, self-guided, community forming, cooperative type of residential developments and so on, and how that can be further extended to cities. By industrialized construction, what we mean, first and foremost, like the kind of technology you use to build cities and buildings definitely has an effect on the type of city you will get. So they compare Atlanta in the U.S. to Barcelona in Spain, and you can also see that it has an effect on the ecological footprint. Same population, order of magnitude more environmental impact. So whilst there is a ready understanding of the benefits of thinking about buildings and cities like cars, and and efficient manufacturing, a kit of parts, and so on. When this has been tried in architecture before, this is the Lustron house. It leaves something to be desired in terms of its mass reproducibility. So we don't want all houses to be exactly without. So there is a social layer missing in all of this, which is what we are trying to address. So whilst we want to take on the idea, the effect, economies of scale of manufacture and assemble type of industrialized construction, we also want to reconnect and upgrade traditional wisdoms. Why? Because there's a lot of intelligence embedded in the way things have evolved in the built environment. So for example, we want to reconnect with some of the technologies and thinking, particularly geometry-based thinking of people like from the 18th and 19th century, or even before that from the Gothic and Renaissance times. These kind of graphical geometric means of designing structure. And not only that, all these geometry-based manuals of construction, so that you didn't need to be a mathematician or a geometer to be able to construct these. So all the geometry was the base language through which construction was encoded, and geometry was encoded in these machines, in these instruments. It was encoded in the way to draw these construction drawings and so on, and even construction instructions. And so we want to reconnect with that kind of thinking. So this is also in a way industrialized construction, where there's an ecosystem of knowledge workers. I mean, this is pre-computer time, but so we see these as very, very relevant predecessors to the kind of effort we want to do. And so this is where we see a significant role for architectural geometry. And by architectural geometry, we mean structure and construction aware shapes. I will try and give you a few examples of that. The first one being this effort, a collaborative effort between Block Research Group, our own team at Zaha, and Architecture Extrapolated that we did in 2018, towards the end of 2018. So this entire thing was constructed in a pit, and all of the material that needed to come to make this came through that little door there. So it and this is in the context of Felix Candela, who was like really one of the early masters of such geometry like structure and construction aware shapes. You can see how thin some of these structures are for the weight they can carry, and highly performative shapes. And also it had the additional benefit that they could be constructed using simple straight lines. So you could create doubly curved geometries with simple ruled or straight line formwork. So this is one of the early examples of what we mean by structure and construction aware shapes. But of course, this came at a price, because you were making the formwork twice. Basically, you were making the shape twice because you had to get rid of the formwork after it was made. So in that context, we did this one where it is fabric formed and it's lost fabric formwork. So the colorful fabric that you see is the formwork for laying the concrete on the outside, and also it penetrates inside. And it was made, the entire formwork was made in a kind of grandma sewing machine in Zurich, and packed up and taken on a commercial airplane on a suitcase. The entire formwork weighs about 55 kilos. It was designed and engineered by the Block Research Group as part of Mariana's PhD research. And then we just made minimum formwork, guide work on the side, and then we pull up the fabric and tension it. And then subsequently, architecture extrapolated, coordinated all the construction workers, and the extremely skilled Mexican labor in terms of casting concrete against gravity, against highly curved shapes.
Shajay, may I interrupt you just a second? When you talk, the video sound is too loud. We cannot hear you.
Okay, yeah. Well, okay, fine. You mean like the sound of the music?
Mm-hmm.
Okay, I don't have any more music in it. Yeah. Yeah. So I mean, it's a similar. Yeah, so we've tried to expand on these ideas like previously, that everything you see here is somewhat like the shaping of it is related to how it performs structurally, and or how to construct it. So for example, all these lines here on the fabric are related to lines of equal tension. So there is no wrinkling. So these are not arbitrarily drawn lines. They're drawn specifically uh, to minimize the amount of wrinkling when you stretch the fabric and so on. And also these kind of shapes allowed us to create many little shapes within a small gallery of 1,000 square meters. There were 25 different stories that were told in a small gallery because of like these kind of added freedom that that curvature and these kind of complex shapes allowed us to utilize. So yeah, so this is part of the constructional aspects that the tailor, for example, wanted to stitch it in this way at the bottom right, and then we wanted it to be stitched in the top right. And so in the end, what was constructed over here was some hybrid between what we wanted as a design team and what the tailoring team could achieve. And the other benefit of this is that the same technology can be used and same thinking can be used, whether it is a gallery for mathematics in the heart of London or a school for refugee children. So this was designed to finish to prototyping an installation within 2 months. And so it arrives on site and then you just open it up like an umbrella. Um, so, and that's what and here's another example of what we mean by architectural geometry or construction and structure aware shapes. So this is related to curved origami. And curved origami is very, very simple. Physically speaking, you cut away paper and score paper, and then you fold and you get curvature for free. And this curvature is obviously structurally beneficial. And it is also beneficial in the range of parametric variations you can create in very, very intuitive ways. And also create very complex performative geometries in very simple ways. So all of these, both these two shapes come from a single piece of paper, a single piece of plastic, like with these scores, and you can fold, and you can also literally scale these things up from small to large. And it also has a predominant history all the way to Japanese manuals in the 10th century to contemporary art and science. So for example, David Hoffman, Ron Resch in the 1970s picked this up and tried to make it computer design friendly, look at the mathematics, look at the computer generation of it. And subsequently, it's also been picked up by, studied extensively by Tomohiro Tachi in Tokyo and others. Incidentally, this was taught in the in the Bauhaus in the 1920s as part of the curricula for architects. And so we're trying to pick that up and augment it with some digital tools and then allow us to make these kind of curved geometries. This was made in India in 2012 with just a laser cutter. And so you score and you fold by hand. And within a few hours, you get complex geometry, which is structurally beneficial. And it also is materially effective because everything comes from flat sheet material. So similar ideas that we did for our effort in the Venice Biennale. So all of the intelligence is mainly in this geometric ways of arranging material. So this is 6 meters tall and 1.5 millimeters thick aluminum. And so it is self-supporting mostly because of the curvature and also the kind of folded plate action. And another example, the last one, is these benches that we made in the Science Museum, which again looks at like historic techniques of describing geometry that can be cut for stone cutting as the discipline of stereotomy, and then trying to revisit that in the context of robotic hot wire cutting. So you can go from a full block of foam to the formwork in about three and a half minutes. So there were 16 different benches, all delivered on time, on budget. And so and it also reflects like the quality of the finish is naturally because of the way the form was cut, and so how it was designed reflects these smooth finishes and so on. So that's more like that's what we mean by architecture geometry. What are the features it shares with modernism? Of course, it has a common ground in the sense that it follows the trajectory of teaching, learning, and doing. And like modernism, like the Maison Domino, it is somewhat aware of the technologies of engineering and construction aware. And also there's a new flexible diagram to design with these kind of shapes and with these new technologies. And it is also realizable in a spectrum of building economies from India and China to Latin America, where we have done, and also in every place in between. Um, and what is different is that it has far more degrees of freedom. So as we mentioned before, like this is allows in a very small space to tell very many different spatial stories. So for example, here we were housing a very somber uh, artifact related to eugenics alongside like more playful ones, all within a small space without having to make special rooms for this. So it's a high curvature offers high degrees of freedom to articulate spatial variance and experiences, user experiences. And curvature is beneficial ecologically in the sense that you can use very, very weak material, like in this case by Block Research Group, using just raw earth, very weak material in good structural shape. So you can span with very weak material, which means very little embedded energy goes into it, because for large part of the strength of materials comes from pumping energy into the material. So, and this is the principle that they are also now using to produce floor slabs, which are 70% lighter, and they save 25% of space, all because of like a bit of curvature and also the ribbing on the top. So much so that that recently the BBC even picked up like that these ideas of sustainability with practicable ideas of sustainability and the use of appropriate structural shapes to save material, to save energy, and also have a longevity in construction. So that's what we mean by industrialized construction. Of course, factory made, manufacture and assembly, but also to reconnect with historic past and particularly the wisdoms of the past. So I will end with like this kind of real world example of where we are trying to bring these two things close to each other. So it's a small island in off of the coast of mainland Honduras, and we are trying to make these kind of housing integrated into the landscape. It's an effort between Zadid architects, AKT engineers, and Hilton Moran and environmental engineers. Honduras has a lot of locally certified timber. And so what we are trying to build here is that offer choices and allow people to form communities, or at least shape their own, embed their own choices and like interactions with people. So we as architects and engineers first lay out these kind of pixel grids according to some global parameters like views and solar gain and so on. And subsequently, users are able to pick on those 3D pixels, and they can choose whether they want to get expansion rights or occupation rights, and view rights and so on. And then they can negotiate this with their neighbors. And subsequently, they can also choose their own internal layouts, whether they want the living room facing the ocean, or they want their bedrooms and so on. And so just to give a sense of like the amount of choice that designers have to design for, just picking 3 pixels out of a grid of 9, already you can see how these choices can multiply. So in this first attempt, like we are restricting the choice to a highly curated set, but hopefully in the future we can expand out to more choice. The other effort that we're trying to do is to import machines and not like import the entire house. So we want to import the machines and then use local material and bring the benefits of digital fabrication to even low investment, early startup type of communities, and also synergetically work with the quite highly skilled labor that's available, human labor, carpenters, masons, and so on. Augment that skill with like very lightweight machinery and low capital investment machinery, like things that can come in a shipping container. And so it can build things which are much bigger than the machines together with the humans. And that also allows us to revisit the supply chain in a way, like how can we turn raw material into the house, and where can we innovate along this chain, um, before raw material becomes a house. So, and that's like where we are. To conclude, then, what we mean by citizen-centric cities is a kind of digitally enabled marketplace, interaction between people with investors, like it could be the state, it could be private investors, it could be some partnership, joint venture, producers like architects, engineers, contractors, and the eventual consumers, which are like the end buyers or the occupants, the inhabitants, and so on. And regardless of who these main stakeholders are, we believe that like the gamified aspect of resource allocation and decision making is an important criteria, so that we don't have to make very many rules. Like we just set the as few rules as possible and allow for negotiated solutions to take place. So to improve the agency of the inhabitants in the decision making, in the or to allow for them to participate in the decision making process. And all of this is definitely has to be built upon the guarantees offered by industrialized construction, so that at least some of the variables are taken out. So what you see on the configurator or online is relatively close to what you will get in reality. So that's where we begin to see that there is a cyber physical coupling between our in the of architecture and urbanism in the near future. And we're all motivated by the same aspects of like how we can have effective resource utilization, i.e. sustainability, and social and physical sustainability. And all of these ideas have definitely been at least considered and done before. For example, the Bauhaus, for the short time that it was active, it had like an outsized impact. So they even they did definitely look at all the things that we are now looking at, like knitting and weaving and origami and curved origami and so on, in their workshops, in their teaching. and some of this led to like highly impressive, aspirational showcase buildings, perhaps, and also a lot of this made its way into the housing of the time. Perhaps where modernism did not succeed as much is in the city scale, like it left some to be desired, and that's where we want to succeed, where modernism didn't. And we think the path to success is to use participatory platforms to solve the problems of the 21st century. Platforms that allow choice and negotiation, and also using technologies, design and construction technologies that allow people, that connects with the past, is upgraded using digital technologies, and allows architects to tell stories whilst physically performing well. So with that, I thank you for your attention, and I thank all the organizers again for the opportunity to present some of these ideas, and I'll be very happy to answer any questions. Thank you.
Thank you so much, Shajay, for your presentation. And it's so nice to see the progress since I have seen your work in Bangkok last year, and especially in the direction of participatory cities and participatory housing. Sorry, I can hear my own voice, so echoing.
Yeah.
I don't know what's wrong. Anyway, let's take a question. I'm taking over Ben Surapong because he has to run for another meeting. We have a question from Marie Davidova, one of our session chair. She said, "Thank you for a very nice talk. It gave me new hope in Sahara architects. I am wondering how do these ideas cope with the Patrick Schumacher's opinion that our public space should be privatized?"
Sorry, if I can kind of frame the question, or if I understood the question correctly, how these ideas work with Patrick's ideas related to privatization of public space. Is that the question?
Yes.
Well, I mean, so first of all, Patrick is he has multiple hats. On the one hand, he's a academic and a theoretician, and also he's a principal and the majority holder of Zadid Architects and so on. So, and the way Patrick posits things is for discussion and debate. It's not to be taken as like a dictate, right? And so how so part of what he says is also provocation. So so in that sense, like, we do all of these research work in subsequent or in relation to such provocation, so that we have considered and informed responses to the provocation. That's one level of how it relates, and the other, the way it more fundamentally relates is in the spirit of inquiry, is that, you know, we shouldn't just be averse to something just because person X said it. So we want to inquire without having a ideologically predisposed response, and that's fundamentally where we this is aligned in the spirit of inquiry. So it's not so it's not trying to like the provocation aspect, or it's not just what it seems like on the surface, right? Like, it's not these sound bites, it's not the headlines. I mean, we are definitely being dedicated to this for at least the last 20 years. These ideas of participation and agency of inhabitants, and also we're not averse to these things taking their own a different route. So this is our take on it, but like we are also open to anybody else taking it in a slightly different direction, whether if they think that, you know, public spaces should not be privatized, and like, but they can actually make it work, like people will have agency. I mean, we are all for it. And actually, you know, my studio is constantly in conversation with other people in the in other institutions who are taking a slightly different approach to it. So yeah, it's in the spirit of conversation and debate, and so that all sides of the debate get better.
Okay, thank you, Shajay. I hope that answer your question, Marie. We have 2 more questions from Skylo. May I know if the game system are accessible?
Not yet, but there is plans to make it available once we can develop it through a few more iterations, just because we want to be right now focused on getting it done rather than supporting you know, its maintenance online. Like, so similar to Compass and other things, effort by others, you know, Block Research Group and Bureau Apple that I mentioned, that is coming towards after 5, 6, 10 years of like research, and I think so we will also see a similar future for this part of the research, where we will make we'll definitely make it available, just not in the immediate future, but perhaps towards summer of 2021. But there's like plenty of others. I mean, a lot of the base technologies are available already through Facebook and through Unreal and so on.
Okay, thank you. Next question from Hugo Mulder. Thank you, Shajay. Wonderful work and really amazing presentation. My question, how does the Honduras work address changes in habitation? So once owners sell their place, can the system be adjusted to the wishes of new owners? Good question.
Yeah, hey Hugo. I assume you're the same Hugo from Arup, or used to be in Arup. And yeah, no, the idea is quite simple. That like, yeah, so it is a kind of digital twin. So once the first owners buy it, they can then sell it or exchange it for other things, and then of course, like, there's only some amount of flexibility when it comes to structural changes, you know, but within what is possible structurally, and also in the mechanical systems, like, you know, we cannot move toilets around so much. Yeah, there is the idea is for people to transact freely or exchange freely. So their rights, the view rights or the expansion rights, or even occupation rights, to with as little interference as possible. And also just the fact that there is the expansion rights means that people can grow their house. For example, like some of the users are already talking about, you know, right now they have 2 children, but then they will go to school and or college, and then they don't want so much, and so we are thinking about how that can be then allocated to the community, or they can be on a Airbnb system, or like a kind of, yeah. So definitely we're considering a expansion system and a contraction system, so it can grow reasonably from, let's say, 35 square meter. Each pixel is about 35 square meter to maybe 3 or 4 pixels. So the maximum choice we allow is 5 pixels. Otherwise, the number of combinations that we have to account for is like exponentially grows with every additional pixel that we allow choice for.
Okay, I hope that answered your question, Mulder. Next, from Christophe Perla, one of our session share as well. Hi, Shajay, great work and great to see you here. In some of the work you didn't show today, you often touch on ideas of imprecision from low-tech crafts, such as in your concrete shell pavilion done in India. And that is often by force rather than choice. How has a confrontation with inaccuracies by building across the world in the recent decades affected your attitude towards precision and control on site?
Yeah, great question. And hey, Christoph. Yeah, no, I mean, like a lot of our collaborators are from a time when digital technologies were nascent. So just getting things done was already an achievement. So precision wasn't as important back then, let's say 10 years ago. And so right now over time, we have come to this kind of idea of, I mean, we definitely don't believe in this zero tolerance approach, but that there can be greater precision achieved by transmitting the geometric logic of construction. So, I mean, again, this is not a new idea, but like the way the hanging chains were literally the method of drawing stuff on site. So it wasn't that like it was computed first in a studio and then drawings were made and then measurements were taken on site. Like they would just literally hang a chain and do stuff. And also how domes are constructed with a guide chain. So there's a lot of these ideas already in new contracts, even like the idea of even BIM as it should be, not the BIM way it is predicated on the idea of transference of geometric logic of construction, so-called method statements and method contracts. So that's our idea, that like if you can describe a method that contractors and others have to follow, that is going to yield greater precision in terms of structural suitability, in terms of constructability. So, and also when we use like, physical forming methods like curve folding, the material automatically takes the shape. Like it's similar to hanging chain, that by applying appropriate force, like you end up with the right kind of shape without having to describe it millimeter by millimeter. You don't have to make too many drawings. You only have to describe the method. So that's where we see another benefit of architectural geometry is in the realization of complex geometries with simple, effective means. And so whether it is in the Science Museum in London or like a school for refugee children, it's more or less likely to have the same precision. Some of the finishes will obviously be more durable the more you pay for it. But yeah, the structural and material economies are not sacrificed because the methods are transmitted, not the frozen shape. Yeah. And again, it's not a new idea. Like people like Heinz Isler and Gaudi and others did this a long time ago, and particularly so also in timber, I think. Like, yeah.
Okay, thank you so much, Shajay. I'm afraid we're running out of time. So I would like to thank you again for joining our virtual conference. Actually, we would like to invite you back to Bangkok because it was supposed to be a physical conference, etc. So looking forward to the next time you come here. Thank you.
Yeah. Thank you. Take care. I mean, I have time if there are some questions that need to be. But
Okay.
yeah.
Okay, we can save the question and send you by email probably.
Yeah.
Okay, thank you.
All
So
right.
yeah, bye-bye. So let me announce quickly the next session will be session 4 by Mark Aurel Schnabel and postgraduate student consortium. So please join the next 2 parallel sessions. Thank you.
So.
Thank you. Bye-bye.